Worksheet 3, number 10. Secant squared minus 2 tangent squared equals 0. I can't factor it. So what's left? Wait a minute. There's an equation somewhere that has secant squared and tangent squared in it. Right? One of those identities. The second or third one, depending on how you order them. I know that sine squared plus cosine squared is 1. If I want tangent and secant to show up, what should I divide by to get the one that I want? Yeah, let's divide by cosine. So that means that tangent squared plus 1 equals secant squared. Okay, well, I could solve this for tangent and plug in secant squared minus 1, but I think I'd rather just like secant squared is tan squared plus 1, so let's put in tangent squared plus 1 for secant squared. So I was hoping somebody would ask this because we did not do one like this in the notes yesterday. We mentioned it in the notes as an example of, what did we say? Use trig identities if you need to get it to all one trig function. So let's see, tangent squared minus 2 tangent squared is negative tangent squared of x plus 1 equals 0. So if I move the tangent squared over to make it positive, tangent squared x equals 1. Square root both sides. So what's the tangent of x equal to? Sort of. Plus or minus square root of 1. Again, when we're talking about plus or minus, you remember it, but when we come in, after having slept and not seen one yet, do you remember to do the plus or minus? I hope so. So tangent of x equals plus or minus 1. The good news, though, with the plus or minus, as we talked yesterday, means quadrants aren't really an issue because it's all of them. Right? All students take calculus, but who cares? I want the plus and the minus. What I'm more concerned about is what angle has a tangent of 1? What's the reference angle? It's the over 4, the one in the middle. Because tangent sine over cosine, so this means sine over cosine is 1, so they're equal to each other. So all the over 4s. Pi over 4, 3 over 4, 5 over 4, 7 over 4. But the main problem with that problem, or the main part of that problem, was that trig identity to start with. Mm-hmm.
For the questions like number 14 and 13, when you multiply, so it's like 3x equals all those things, is 12 the new, is that 1 pi or is that 2 pi?
Can we do one of those?
Yeah, sorry.
You got a preference on which one? They look pretty similar because they both have a squared and they both have a 3x. Yeah, they're pretty similar. Do you care which one? No. Anybody care which one? 13 or 14? 14? 14 it is. So I'm going to add 1 and divide by 2. So cosine squared of 3x equals 1/2. I don't have the space to show every single algebra step. Square root both sides. So cosine of 3x equals the square root of 1/2. But that's not quite right. But everybody knows it's plus or minus because we just did one of those. Square root of 1/2 doesn't look like a unit circle value though, but I need to fix it. And if you've done enough of them, you know what the fix is even before writing it out. Root 2 over 2. So cosine of 3x equals root 2 over 2. Oh, plus or minus. Yeah, I was just fixing to ask what quadrant are we in, but plus or minus means it doesn't really matter what quadrant we're in. We're in all of them. So root 2 over 2, where is the cosine equal to root 2 over 2? That's the over 4s. That's the ones in the middle. And it's plus or minus, so again, I'm not worried about all students take calculus. So 3x equals pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. Now I realize what you were asking. Because how do we handle this 3?
Or will we have to do this?
Yes, I need to triple the number of solutions, and then I'll divide by 3. So I need to add 2 pi to each of those twice. Right? I need 2 more sets of solutions, 2 more sets of answers. So let's do it this way. If I add, let's see, over 4, that would be 8 pi over 4. So 9 pi over 4, 11 pi over 4, 13 pi over 4, 15 pi over 4. Yeah, at some point you might recognize a pattern, and instead of adding, just follow the pattern. That won't always happen, but you see what the pattern is for these answers?
Yeah, it's odd numbers.
Yeah, 1, 3, 5, 7, 9, 11, 13, 15. Again, that won't always happen. Well, it'll always happen, it just won't always be as obvious. So the safer bet is to just add 2 pi again.
Then we have to do it one more time. Right?
17 pi over 4,
Because we just want 3 sets.
19 pi over 4, 21 pi over 4, 23 pi over 4. And maybe using that word sets, that's a good way to say it. I need 3 sets of answers. So I'm not adding 3 times, I'm adding 2 times. But the motivation is I need 3 sets of answers, 3 times my normal number of answers. So yes, I have 12 answers. And I'm not done yet because I need to. Go ahead, Tyler. Divide by 3 or multiply by 1/3. What about reducing? Are some of these going to reduce?
Yes.
Yes. And it's better if it's my favorite is if none of them reduce, because then you just change all the denominators. My second favorite would be if they all reduce. My least favorite would be some do and some don't. So I just need to be very careful. So if I divide everybody by, if I multiply everybody by 1/3,
You just gotta rewrite everything, just change the color.
pretty much need to rewrite everybody, although I need to be super careful.
Make sure it's not going over 2 pi.
To make sure it's not going over 2 pi. But I was thinking be careful about reducing, because some reduce and some don't. I'll keep the color coordination here. It's a lot of pi's and I'm going to run out of room.
I'll just take my 11 pi and just write pi where I would have the 11. So just do it like that.
I didn't run out of room. Planned it perfect. 12 glorious answers. Somebody who was working ahead yesterday asked me a question about 13 and 14 that you might notice.
Is pi over 4, 5 pi over 4, and 7 pi over 4, they don't change
Well, they did. This one was 3 pi over 4, and when I divided by 3, it became pi over 4. So it was 3 pi over 12, and then it reduced.
So is 12 is that 1 pi or is that 2 pi?
What's that now?
Or like pi over 12 is the 12. Is that 1 pi or is that 2 pi?
That's 1 pi over 12. Pi over 12 is 1/12 pi. Oh, somebody mentioned making sure we don't go past 2 pi. 23 over 12, that's less than 2. It's almost 2, but it's less than 2. So we didn't overshoot here.
And you always want us to reduce?
Yes.
He didn't reduce.
Oh, it did it not?
No, on 13.
On 13, it's going to kind of start the same way. Sine squared of 3x equals 1/2. So sine of 3x equals plus or minus root 2 over 2. Well, that's sine and cosine. It's basically the same, right? So you could go through all the process, or you could say, hey, wait a minute. See number 14, it's the same from there on out. Because that plus or minus. You don't have to worry about quadrants.
Don't have them do number 3.
Got it.
Scratch 3.
Scratch number 3. Omit number 3. Nope, on the quiz that we'll do in a minute. All right, so we did a trig identity. We did the triple thing. So we tackled the hard ones. Is there anything else you want to see? Of course, that means we haven't done a factoring one, like 1 through 8. Any of those? Number 6. Number 6. Sine squared minus 4 sine x minus 5. Did you factor it as it is, or did you put in a u substitution there?
I just factored.
Okay. So it's got to be sine and sine to make sine squared. The only way to get 5 is 5 and 1. And I think I know where this problem's going now. So minus 5 and plus 1. Again, if you don't like that, then you pause and say, you know what, let's turn them into u's. And that's a little bit easier to factor. And then put the signs back in. And you're right back to where we are now. But it is a lot easier looking at u's than looking at signs. So sine x minus 5 equals 0. Sine of x plus 1 equals 0. Okay, sine of x equals 5. I don't recognize that as a unit circle value. If we think about the graph of sine, how high does the graph of sine get? What's the maximum it gets up to? 1. And what's the minimum it gets down to? -1. So where is the sine of x equal to 5? That's like way up here. It's not. So careful saying no solutions. When you say no solutions, you mean to this part of the problem. You don't mean for the whole thing. This doesn't add any solutions. Sine of x equals -1. That would be down there at 3 pi over 2. So factoring, square roots, identities, the double thing. Make sure you set it equal to 0. We said that 3 times yesterday in the notes. I'm looking at the quiz. That's what's making me think of things here. GCF. But yeah, I think we're good. Anything else?